Hi everyone, my name's Donkey, and today we're back on the mouse pointer series that we've kind of started last video. We didn't get very far. We got to the point where we changed the background colour and we added some movement as well, very basic movement. We're not focused on the movement, we're focused on the mouse pointer itself. So what we're going to be doing in this video is starting some work on the object mouse, which it's kind of misleading actually. It's not cool. Let's change it to controller, because it's actually it never follows the mouse, it never goes anywhere near the mouse. Actually, it's just controlling the mouse, but not even that, it's controlling the arrow that points towards the mouse. So we're going to make a create event, we're going to make a step event, we're just going to leave them for the moment, but in the create event we're going to add two new variables, ax and ay. In fact, let's make them a little bit more easy to read. We've got enough time to, so we're going to call them arrow x and arrow y. These are going to be the coordinates for the arrow. Now of course the coordinates aren't everything, because even if you do have the coordinates, we're still going to need a direction, but the coordinates are very important. And we'll go into how we're finding these later, but for the moment we can just set them to 0. It's not necessary, it's just good practice. So now we've got that set up, the first thing we're going to want to do is make some it's the difference, I'm not trying to think how to word it so that'd be neat. It's the, I'm not sure, let's see what I wrote here. We're effectively just minusing one from the other, changing x and y. Let's call it, yeah, the difference in x and y, I guess is better. And let's get rid of that, it's horrible. What we're going to work out is two variables, so not going to use var even, we're going to keep them local but not temporary, so permanent local variables. So we'll call it changing x, I guess. That would make the most sense. Changing x equals, I've got to make sure it's the right way around, so it's mouse x minus the other one, minus object, oh no, mouse no, object player, what am I about, dot x. Same goes for change in y, except for mouse y, dot y. Now that's pretty simple, and this was where I got to every time I'd start off with this basis. I've said before, it took me a while to actually get this system complete. So then what I started to do was go down the lines of having a gradient, because obviously every line has a gradient. So if we're taking, let's get paint up, and I'll try and demonstrate. If we've got a point here, which is our center, I'm going to start using these instead, I think. We've got another point here, then we effectively have a line between the two here. Now what I originally went down the line of was making a equation thing that worked out the gradient of that line, and then from the gradient you could find any point. However, finding any point was hard to find a specific distance from a point, because you then had to go into Pythagoras and finding out that sort of thing. At which point I realised, no, this is way too complicated. We're going to go down a slightly different road, which, get it up, was first of all setting a radius. That's really simple. You can just pick any number you want. I found 30 worked quite well for this size player, but again, it's entirely up to you. Let's go 40 for this and change it up a little bit. So this is all still relatively simple. The radius is the distance here, and if you imagine we've got a circle here, and imagine that was in the middle and it's meant to be kind of more there, then this would, if you had the mouse there, like here, then it would draw it and it would still find that point there. That was something that was important. It had to do that because otherwise it looks a little bit weird. You could have it, and I did make it before, where this is a really easy one to do. You can do this one yourself. So you've got these 2 points here, mouse and center, and it's here, and it would just do there, for example. But then if you had it further away, it would also be further away. So that's another way of doing it. But again, it's entirely optional way of doing it. But we're going to stick to the way we are running it at the moment. So what we did next was find the distance. Again, relatively simple. Equals, and there's a built-in function called point distance. And point distance, what you do, put in your distances, make sure that the distances do line up, so mouse X and mouse Y are paired together, and then object player.x and object player.y are paired together. That's important. Now this is where the maths side of this comes in. So we've got this here, and I'm going to break it down a little bit. So we're going to start off with just this section here. So tx equals change in y in x divided by distance. So we're going to write that up first. So the arrow x equals change in x divided by distance. Now you've got to imagine what this will do. So if we've got our 2 points, we're going to draw them for probably the last time now. So we've got our 2 points there and there. Now we've got our line drawn between it. This is the distance from here to here is our distance. Then we've got the change in x. So the change in x is measuring from here to here. Now what this is doing is it's taking this distance and dividing it by this whole distance so that it gets it at the point of which is equal. So that the point along this line is equal to, if we do the same thing on the y, take here and divide this by this, is also equal, and it's on the line. Now if we did just do that, and we're gonna also just leave a little gap and put plus object center, not center, player dot x. Now if we did this for both of them, we copy them, so it's the same, arrow y, change in y, object player dot y. Now if we run this, you'll see it'll kind of work, but we will never see the arrow. The arrow doesn't ever get okay, never mind, the arrow doesn't get drawn because we've not got a draw event. But the problem with this is that it's not quite big enough. So imagine our player is about this big. It's probably a bit of an exaggeration, but this point here is still within our circle, square. We never see it. So to get around this, we've got to times it by a set value, in this case our radius. So then what this does is it then sets a certain size circle that is bigger than the square, like that, and it then says, you know, we're going to find this point here. And the way it does that is it times that value and that value, the x and the y, by the set radius here. So another way of thinking about it, which is the way I thought about it, was imagine this is from here to here is 1 unit, from here to here is your r unit, your radius. In this case this is 40 units. So this is 1/40th of the way. We want 40/40ths of the whole way to the edge. That's probably the easiest way of explaining it. So just to go through, what we're going to then do is times by radius. And that will do what I just explained. It will set it on a circle that is larger than the square, so that it all looks really neat, really nice. Because whatever we do, we have to have this outside point not touching the player, or not within the player, otherwise it'll look like the arrows coming out from them. So that's going to be it for this video. If you like the video, remember to like, subscribe, always do as what to do, and I'll talk to you in the next one.